Boys and girls, reverse desk raise. That's right, it's a desk lowering. Woo! What's going on, boys? Welcome back to another video. Today, what we're gonna be doing is sitting on the ground. I don't actually have an intro plan for you today, so hey, right now, I'm actually working on 3D animations for a 2D game. It's a long story, but right this very goddamn second, we're working on inverse kinematics for moving the legs and whatnot. That's what we're gonna be doing today. You know what? Desk race time. Back up we go. Oh yeah, baby. So, get cozy, grab you a nice beverage of choice. I've got myself here a nice hot Milan. The candle is lit. I don't know why I have a candle here, but it just kind of adds to the vibe, you know? I like it. Now, I've been thinking recently, right? We're doing fabric IK. Forwards and backwards reaching inverse kinematics, I think is what it stands for. In my head, I was like, how on earth am I gonna add constraints to this? How am I gonna make like a pole target, how it's in Blender, you know, where you can like position the knee and then like your knee fucking like rotates out because it like kind of puts out that. I have no idea how to do that in fabric, and it's gonna be tricky. So how about we don't do fabric? I was looking at the comments of the latest video. Old mate Murray this said a bunch of stuff. Personally, unless you aim to do full body IK, which if you were Jacobian, what the fuck is that? Yucky. Math stuff, ew. I'd do a more traditional two-bone IK. Fabric is a great solve, but it can be super complex when you start creating constraints, needing to create pole vectors, eliminating degree freedom of bones. That's exactly what I had in my head. I was like, how the fuck am I gonna do that? And the answer to that question is not easily. So, you know what I'm gonna do? Problem solved! Yay! Now, I know in yesterday's session, I was like, we're just getting started. I'm gonna be back in 3 hours. And then I proceeded to not be back. Big surprise. It's because I was too busy watching Squid Game. I've seen Squid Game pop up just as #1 on Netflix for ages now. And I'm like, I ain't fucking watching that. I'm not gonna watch whatever Netflix just rams down my throat. But it's actually pretty good. There's a reason that everyone's talking about it. I like it. So far, so good. So yeah, I think literally what I'm gonna do is just not do fabric and just go back to two-bone IK and just solving it with basic trigonometry, which is what I should have done to begin with, but I overreached. So let's figure it out. I still don't really know how to do it, but we'll figure it out in this session maybe and see how we go. All right, do some IK shit, Lamal. Thank you. That is absolutely excellent. All right, so I'm gonna explore this bad boy. Actually, let's make sure the animations are working still. All right, that's a little bit of a problem. Let's recalculate the weights real quick. So now, nothing will happen when it does this. There we go. Weight painting, done quick. All right, let's export that bad boy. So now, I'm gonna open a new Leonardo page. By the way, this app is called Leonardo. Absolutely excellent. 10 out of 10 would sketch again. This is what is happening. We've got this joint, we've got this joint, we've got this joint. So however we move the foot, let's say we move the foot upwards like this. This guy is gonna have to bend out in the direction of a target. I don't know how any of this really works, but like that's the gist of it. That's what's happening. So we just need to figure out mathematically how all of this kind of comes together and do all the trigonometry stuff involved in it. Boys, we don't have much time. I'm stuck inside a video saying the same thing over and over again. Hi, my name's Thomas Randall, and I'm here to tell you about the benefits of becoming a member on my website. Aside from supporting yours truly and helping to hire new team members to pump out the game more quicker and effectively, you'll also get access to all the source code for my game. Don't go stealing it now. I mean, what are you gonna do? Make it for me? You'll also get access to Rando's Digital Garden, which is a second brain run in Obsidian.md. It's a long story, just pause the video if you want to learn more. You'll also get access to the Crack Den, which is a lovely little Discord community. There's a bunch of cool stuff in there. Nice. And last but not least, for the time being anyway, you'll get the randy.gg monospace font to use in your code editors. Or just wherever else you want to use it, I guess. If any of that tickles your pickle, you can actually get a free membership if you have an Amazon Prime account. Just follow the directions over at randy.gg/prime, link in the description. That'll give me a free $2.50 US per month if you keep on renewing it, all thanks to Daddy Jeff. If you don't have a Prime account though, but would still like to support me, it's $4 US per month to join up. And I'm trying to make it as worthwhile as possible every single day by growing this little community of ours and adding new stuff to it. Just type randy.gg into your browser of choice or follow the link down in the description. Boys, we don't have much time. I'm stuck inside a video saying the same thing over and over again. Oh, fuck. What should I Google? That's always the question. I saw something the other day with this. Yeah, this fucking horrifying thing. I'm just removing that out of principle. Jeez, fucking, that is horrifying. My God. R.I.P. I guess we'll never know what that bookmark was. 2 burn IK math. That could be good Google. 2 burn IK math. There we go. Plenty of stuff. I don't know why I didn't think of that. Oh, this looks good. Hell yeah. This looks hella yummy. Thank you, Grimmett. This looks hella good. So let's work our way through it and see if it's what I need. Most animation programmers know that in the case of 2 joint, there exists an analytical solution to the inverse kinematics problem. Given the configuration of joints shown to the right, where A is the hip joint, B is the knee joint, and C is the heel joint, T is the target location for the heel, we can solve the IK problem with 2 simple steps. Thank you. Oh, you know what? Where would we be without amazing people like this making blog posts? So goddamn great. Resources in description if you want to see this yourself. All right, guys, I hate to be that man, but our time has come. Take care. I'll no longer be seeing your lovely messages because I got some goddamn work to do. Let's get cracking. Let me set up my environment so I can actually kind of see that. All right, let's do a few things. I don't really want to scale him up because that might fuck things. You see, now it messes up my mouse position. Maybe because I'm not factoring in transform. I'm just trying to figure out how to debug this. I could do it with this, right? But then I can't really see it from the side. Oh, you know what I just realized? It's because I'm doing this. So now if I go back into animation, do this. Hey! I actually know what I'm doing. All right, so I can do it from here. Awesome. This is gonna be a perfect way of debugging it. So we'll go to 45 degrees and that'll be a really nice angle. Yes. So right about here, it's at max extension, but then as we move closer, it gets, of course, closer and closer to 0. And then same thing goes for the other side. At any point, we can only extend out to a max of 0.74, which is the whole length of the burn. Awesome. Wow. It's crazy that copy code actually works. Who would have thought? So what's up next? Next, we got the current interior angles of the hip and knee joints. So of A and B. For this, we just use this dot product method. So this angle and this angle based off of the length between there and there, I would imagine. All right, so now we've got those two. What next, Mr. Magical Article? We clamp the output of the dot product in the range of -1 to 1 while passing it through ACOS. This removes the occasional numerical errors because our floating point and taking ways go back. Cool. You can now use the cosine rule to get the desired interior. Oh, dude, I remember the cosine rule. I dead ass remember that from math class. I was just sitting in there. I'm like, what the fuck is this? That's crazy. I can't remember it. I remember the cosine rule. I recognize the name. Cosine rule to get the desired interior angles of these joints, which produce a vector from the hip to the heel, the same length as the vector between the hip and target. See, I would like a pole target, but baby steps, baby steps. Yoink. That should compile. All right, moving on. With the current angles and the desired angles, the final angles by which we have to rotate the hip and knee joints are just the difference between these two values, while the rotation axis is just a cross product between the vectors from the hip to the knee and the hip to the heel. Since we are working in the world space, we have to first transform this axis into the local space of each joint. These rotations will be applied locally. The inverse of the global rotations of the hip, AGR, and of the knee. What inverse of AGR and BGR? You see, I can do that. I know how to do that. So there's one thing in here, which I'm gonna need to do myself, which is the AGR and BGR. So the global rotation of A and the global rotation of B, which, you know, is quite straightforward. We kind of calculated that before with a bunch of fucking dumb stuff, but I would like to pull that out from a matrix. That would probably be easier. In fact, I think I can actually do that because that's what I did before, kind of. So we're multiplying quaternion by this. Okay, cool. All right, hold your horses. I think I understand it now. Maybe, we'll see. We need to multiply PvP. Yo, we PvPing up in this bitch. What I'm literally doing is trying to multiply them like they're fucking vectors. I look at this and it just goes fucking just through my eyeballs. Alright, I'm so incredibly lost, but the people of chat are far smarter than me, and I'm a dumb that can't even multiply a quaternion by whatever the fuck this is what it is, alright? I tell you what we're gonna do. We're gonna create a way for people to do the work for me. And actually provide proper explanations that aren't kind of limited to Twitch chat, because you can't copy and paste code into Twitch chat. I need to read a book, bro. Hop a call, explain. All right. I'm gonna hop in the call and you can just explain it to me. Dark Ninja, my man, and Sand.
Hello.
I've done a fucky wucky. I don't know what I'm doing.
Hi, yeah, sorry, my mic.
How you doing, bro? What's going on?
I'm sorry, this has been a little bit painful to watch. But yeah, so you're trying to work out this angle axis issue, right?
Yeah, well, first of all, I'm trying to figure out if this even is an angle axis. Like, what is this?
Well, it looks like you have the setup for an angle axis, right? Just a float, just an angle and then an axis, and that will define you a unique quaternion. Right? That's what the tutorial is telling you that you need to write.
All right, so cross is when you have more data, you're just getting the XYZ, that's the vector part of it, and dot is you're condensing that down into a float.
You're condensing it down into like how are they, what are they in relative to each other.
Gotcha.
But the cross is super useful, because just to pick out that third orthogonal vector.
So that leads me back into this.
So are you treating your individual bones as objects and then just applying the transform matrix to the points?
I don't know.
I mean, you could treat your bones as imaginary lines and then just have the dot, have your position in the center, and then you do your transforms from there.
I don't call them bones, I call them joints. And then, so it's literally just one matrix, and then you've got the translational part of it and the rotational part.
Is the origin in the center of whatever your joint or bone is?
Sure. Okay, we have two quaternions, R0 and R1, which have been constructed based off of the axis and some other real portion from sine rule math. Alrighty, so I think those two variables should be the right rotations now. So I guess moment of truth. Oh wait, no, there's one more step. Multiply this rotation to the right of the hip joints rotation. Oh, does it mean to the right as in it's a second?
One side note is quaternions aren't
Communicative.
commutative, I think.
Commutative?
Yeah, you can't interchange the order. So it looks like they're post-multiplying everything, so everything's on the right.
Yeah, so that's what I mean.
And then you might have to define either a wrapper type thing or just a completely separate one that can function that can do the other order of multiplication.
I guess this is the moment of truth. Did everything work? I'm kind of scared to hit the run button. Let's do it. That's definitely just not working at all. Alright, future Randy's in for a treat. That was quite a bit of fucking math, and my brain is incredibly numb. I guess we've proved one thing today. Learning is a whole lot better when you've got help. I feel like I'm gonna be using this a lot more now that I can just pull in people from Twitch chat and kind of have them walk me through the problem. Well, we tried our best. I tried my best, working my way through a tutorial and copying it. It didn't quite give me this. This is what I'm looking for though. Time to call it. Thanks for watching me struggle through this and help me along the way. We'll pick this up another time. Alright, nothing else to say really. Catch you later. See you in the next one.